Process management. Last class we understood about the differences between program and process. For example, if you have written a C program, example.c, and this program will be given to the compiler, and what will compiler do? Compiler will just convert the high level language program to a low level language program, which is machine language, which can be executed on computer. So now compiler is going to generate something like assume that a.out. So a.out is a file which contain executable code. Executable code means the machine code. Example.c and a.out both are programs. And now this program is going to reside in the hard disk of your computer. Hard disk means the secondary storage. Primary memory means RAM and hard disk means secondary memory. Now this program will generally reside in the secondary memory, and now in order to execute it, the operating system will take that program and then put it into the main memory and then start executing it. So when it puts in the main memory, it will create some kind of structure, some data structure. So that data structure is going to look like this, and this is what we call it as a process. The process is something which is created by the operating system in order to execute a program. This structure will be created in the main memory, and your exe code or executable code, whichever you want to execute, will be here. And above this, in your program, sometimes you have some variables which are called as static variables. Static variable means these variables will be created once and then they are going to remain forever throughout the lifetime of the process. So they are called static variables. Global variables are also kind of static variables which have to be given access to everything in the process. But now understand that these two variables, static as well as global, are supposed to be created once and they are supposed to be existing forever. So they are going to be there forever. And then the remaining space is actually not divided, but then you think something like this. In any program will contain a need for dynamic allocation. Dynamic allocations means like heap. So malloc, calloc, all these calls. The reason is we don't know what is the requirement we might get. Therefore, we will not declare the data structure unless they are required. So therefore, we have to have some space which will be used by the process later at some point of time whenever it is needed. For that reason, heap. So heap will be here, and then every process is supposed to contain something called as stack. So what is the advantage of stack? For the recursion calls, for the function calling, we need stack. Therefore stack will be there. It is also called as function stack. Stack will be there, heap will be there. Static variables, global variables, and then the executable code. Now after creating this, CPU will take one by one line available in the executable code and then keep on executing them. While executing them, it might sometimes have to refer the static variables which are present in the same program. That is why that will be present in the same process. This entire thing is called process boundaries. So everything that is required by this process will be in this, and operating system while executing this particular process should never cross the boundaries of this process, which means anything that you write here should access only this part. You should not write any access to the other part. Then you will get segmentation fault in case if you are trying to access some other part. So this program is completely resided in such a way that you are supposed to use only the elements present in this part. You are never supposed to go outside and refer something else. So now this part is static variables and global variables, and this part is heap and this part is stack. One important thing about heap and stack is heap will grow upwards and stack will grow downwards, in the sense they both will not grow upwards. The reason is, if I grow both of them upwards, I don't know where to start each one of them. And I don't know, in some program stack will take more space, and in some program heap will take more space. And I don't know which one is going to take how much space before executing it. That is why I want to keep my option open. So whichever takes more space will occupy more space in this, and whichever needs less space will actually shrinks down. It is like this: you are having a book in which from one side you are writing the OS, another side you are writing DBMS. Then you need not write OS from half initial phase and DBMS from the mid page. You actually write it from the opposite sides because you don't know which one is going to take more space. Similarly, we don't know about the heap and stack also. Therefore, this is the kind of implementation we are using. So, this entire thing is called a process. So, this is the program. Either example.c or a.out is a program which will generally reside in the secondary memory. And once we try to execute it, then for this particular program, this entire thing will be created by the operating system. And now this one will be given for execution to the CPU. Now the CPU will take each line from here and then refer the elements here, or use this rest phase and then try to finish the execution. Now we can consider the program as a body and our process as a soul. If the soul is not there, CPU cannot execute. Soul without body like a dead man. How CPU is actually going to identify the process? Like there are so many people in the world, right? Then how can you identify each of them? We are going to use something called as identification card. Identification card is going to say ID number, name and so on. Similarly, when we have these many processes created in the memory randomly, at any point of time, we are supposed to keep track of which process is what and how many processes are there and what is the current state of the process, what is happening with it, is it running or is it blocked, or in order to identify. Every process will now be given an identity card. Now it is a newborn baby. Whenever anything is born, any process is born, operating system is going to give it some ID card. Now that ID card is going to look like this. This will contain all these attributes. One attribute is process ID. So process ID means every process will be given some number. That is called process ID. It is a unique number which will be given to a process in a computer. Every process will get a different number. And coming to this process ID, It is actually different in the sense depending on the operating system. Some operating system will use 16-bit, some operating system will use 32-bit, like that. And next one is program counter. Program counter means while you are executing a process, you suddenly stop the process and again you restarted it. Then from which point should you actually start the execution, which means assume that we have like 10 instruction and say you stop the execution and then you remove this process and then you executed some other process and later again you started this process. Then after this instruction, what is the next instruction you are supposed to execute? So that is what we wanted. So for that reason we use something called as program counter. Program counter will contain what is the next instruction that has to be executed, so that you can keep on executing it without any repetition. Next one is the process state. So what is the process state? There are various states. Next topic we will see that. And next is priority. Priority, it shows importance. So whenever any process is created by the operating system, then it will generally assign something called as priority. A process which is having higher priority is supposed to execute first compared to the process which are having lower priority. For example, if you have an operating system process, then it should be given the highest priority because it is important compared to the user process. Therefore, depending on that, we assign some number. Priority is nothing but a number which will be given to the process whenever it is created. Consider the case of politicians. Politicians will have higher priority compared to common people. Therefore, when they are going on road, the road will be blocked for others. Similarly, when a new process with higher priority enters, then that one will be given higher priority and everyone will be blocked, or everyone will wait until it finishes. So like that, priority will be useful. And now there is something called as general purpose register. So general purpose registers means when you are executing a program, then what happens is the CPU will make use of the registers. And now when you pull out that process, now these registers will contain some numbers. And if you pull out that process and put the next one there, new process may modify the registers. So every process is keeping its own register values as general purpose register. And next one is list of open files. So list of open files means during the execution of the process, some files are going to be opened and some files will be open for reading. Some files will be open for writing. Therefore, you are supposed to remember what are the files which you have already opened, so that later when you again come back for execution after preemption, you should know which one you have opened, so that you will not again open it. Next one is list of open devices. So open devices means you can think of it like printers, scanners and hardware devices, and you should maintain a list of, so every information will be maintained in it. For every process, it will create something called a process control block. In this process control block, the entire information will be present. So every process we get one process control block. Thank you.